Okay, this is Algebra 1, 6.1, Systems of Equations. Systems of equations, guys, are more than one equation on a graph. So we're going to graph them. So because this is graphing systems of equations. Later on, we're going to be solving systems of equations, and there's a couple different ways to do that. So before we go into a system of the equations, let's talk about what an equation is and how we graph an equation. To me, there are two main ways to have an equation. One of those ways you guys like to see a lot is y equals mx plus b. You guys have seen that. Most of us like that, right? So a lot of us like to use this because m stands for what? What's the m? Slope. B is the Y-intercept. So we'll just write that in here so we know we all are on the same lines. That's not slope. And B is our Y-intercept. So let's actually give a couple of examples here of a line in slope-intercept form and graph it, and then we'll show you the next one. So something that's real easy, how about y equals 2x plus 3? Now guys, I'm not really picky on my graphs, and you guys have lined paper for the most part, so I would honestly just make a graph using the lines that are there and just draw tick marks. I've seen students actually physically draw their own graph paper. It's the scariest thing in the world because they do this. And then they try graphing in that, and I don't know what's the point, what's the line that you're graphing, what's the line that you're supposed to have. So please do not use that, okay? Make small tick marks as you go along that you can say go by ones, they go by twos, they go by threes. As long as we're consistent, we're okay, right? Now, what does it mean, or how do we graph these, I should say? What comes first? The x? What do you mean? Okay, if I was plotting points, yes, I'm going to go with x first. Right? Remember, any particular point is x comma y, right? Guys, I'm sorry, my handwriting isn't always the best. But I get x comma y. That's a point. Right. If I was going to plot 2, 3, then I'd go over 2 to the right and 3 up. But what about a line? Which one should I plot first when it's in slope-intercept form? Hopefully by the end of the week we'll learn to just start speaking. It makes it a lot less painful for all of us. We want to plot the y-intercept first. Remember the y-intercept. Y-intercept, as a definition for intercept, is it where it crosses the y-axis. So if it crosses at 3, therefore I am going to count 1, 2, 3. So therefore I put my dot at 0, 3. 0, 3 is the y-intercept. Now we can move slope. How do we move slope? What is slope? Maybe we should talk about what slope is. Yeah, slope is how fast it moves. It can be like that. What is slope, though? We always remember it as what? Something over something. Yeah. Rise over run. Rise over run. How steep something is, right? Now, here's the really cool thing. 99% of the time, you guys will avoid fractions at all costs, yeah? I mean, I like to avoid them if I can. Slope is that other 1% of the time. That 1% of the time where you're like, whoa, 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 I want a fraction because I want to say rise over run. I want to be able to go up so far and over so far because that's the wonderful thing about slope. And so when I look at 2 2 is not a fraction right now. But wait a minute. All whole numbers or any number can be written over 1. And so really, I can make it a fraction. I can make anything a fraction. Just put a 1 under it. That means I have a rise over a run. The rise is 2. My run is 1. They're both positive. Remember, as I am on the x-axis, the one that goes this way, if I go to the right, it gets positive, more positive, right, bigger. And if I go to the left, it gets smaller or more negative. Same thing with the y-axis. If I go up, I get more positive, and down, I get more negative. And so, if I'm going to rise 2 and then go over 1, and they're both positive, that means I'm going to go from my point up to over 1. And so I end up there. That's not the only way I can go. If you remember, what happens if I fall down 2? If I go down 2, so down 1, 2, I'd have to go back 1. Because a negative divided by negative is positive. That's the same thing as me saying negative 2 over negative 1. Negative, negative makes a positive. So I still end up with 2. This is what I do. When I'm drawing a line, or graphing a line in slope-intercept form, I want 3 points. I want your slope, your intercept, your y-intercept. I want you to move slope in the forward position, and I want you to use slope in the reverse position, which means I get these 3 points. And if you notice, my graph is not perfect, and yours probably isn't either. We're not using a graphing calculator or a graphing app or something. But you notice that they kind of form a straight line. So that when I go to connect them, you end up with a straight line. So this was, remember, and I forgot to put the name, oops, not slope, I keep on putting that, slope, intercept, form. Sorry, I should have named that in the beginning. The next part is standard form. Who remembers standard form? What is standard form? AX plus BY equals C. You remember that? So AX plus BY equals C. This is called standard form. What's so special about this one? This one does not give a slope or a y-intercept right off the bat. I could rearrange these from slope-intercept form to standard form and back and forth. But here's the really cool part about this, is that when I see it in standard form, I am going to be able to find the x and y intercepts very easily. And so, the way I do that is I go to the eye doctor and I use something called the cover-up. So, cover-up method. Wow. The cover-up method. The cover-up method, if you're given something like this, that's an example of 2x minus 3y equals 12. It's in standard form. Standard form, guys, remember, we want whole numbers for our coefficients. Remember, the 2, the negative 3, and 12 are coefficients. And they generally like to see x first, the x's first, and x to be positive. Doesn't necessarily always have to be, but that's what they generally will try to make for you. And so what we have here is standard form. And guess what? We're going to graph it. I'm going to call it using the cover-up method. And I'm going to probably more than likely say, someone asks me, oh, yeah, I forgot how to graph this. I'd be like, go to the eye doctor. You'd be like, oh, yeah. And you say the cover-up method. Because what do you do when you go to the eye doctor? They put that contraption in front of your face and say 1 or 2. But generally, they have you cover up one of your eyes and read the board, right? And so that's why I like to say I call it the cover-up method. Because this is what's going to happen. We are going to, number 1, make sure in standard form. That's the first thing you should do, is make sure that you are in standard form. Once it's in standard form, that we have ax plus by equals c, I'm going to start to think about, wait a minute, all x-intercepts and y-intercepts end up being on the axes, right? They're either on the x-axis or on the y-axis. But what's so special about all the values on the y-axis? What do they have in common? What do all of the values on the x-axis have in common? They have something in common. Actually, between the two axes, they also have something in common. They all contain a what? What's that point? Someone name that point. What's that point? 0, 3. Someone name this point. Ooh, no. -5, 0. What's this point? 2, 0. What's this point? 0, -5. What do they all have in them? A 0. Look at that. If I am on the x-axis, where is the 0? This point was, again, -5, 0. This one was 2, 0. This one was 0, 3, and 0, -5. Yes? On the x-axis here, where are those zeros? In what spot? What letter or what spot has the 0? The y. Let's look at the y-axis. Where are those zeros? They're in the x's. It always ends up being that way. So guess what? I'm going to use that to my advantage. Now that I know that I have my problem in standard form, I am in step number 2. Going to write out intercepts. And what do I mean by that? I write these things. Intercepts are points, right? All of those points that we just identified could very well be the intercepts to our problem. More than likely they're not. But they all seem to have a 0 in the x or a 0 in the y. Technically, most lines have an x-intercept and a y-intercept. Would you guys agree? As long as it has a slope other than 0 or undefined, it's going to cross through both axes at some point. So therefore, I am going to force it to happen. I am going to place a 0 in the first x position on one point, and I'm going to place a 0 in the y position of the other point. These can be switched around. That's perfectly fine. Why? Why can I do this? Is because I am going to place this 0 in for x up here. And what happens when I say 2 times 0? It's 0. It goes away. Guess what? I'm going to use the cursor to do it. I'm going to cover it up. Hence the cover up. So when I cover it up, it's gone. So now all we're left with is -3y equals 12. Can you solve that? What's y? Negative 4. And so, y is negative 4. And we're going to do the exact same thing with the other point. The other point is I'm going to place in the 0 for the y. Gone, right? Because negative 3 times 0 is 0. And when does 2x equal 12? X would have to equal 6. Step 3 says write out intercepts for 2. How about we plot points, draw a line. My steps, guys, I'm trying to be as general as possible because I don't want this to be just for this problem. I want this to be for all problems that you are going to encounter. So, I'm going to erase all of this stuff here, I guess, the stuff that we created to get you there. Redraw my axes. Okay. Now you just have to plot it. Where does 0, negative 4 go? 0, negative 4 is on the y-axis, down 4, yes? And then, oh, I'm going to run out of room. I got to go over 6. I cheated. I made it a little bit smaller. But you guys agree that I went 6 to the right? Stake to claim. And here's the cool thing. This is why I like standard form. Is because now all I have to do is just connect those 2 points. And you just drew your line.